Hey everyone, welcome back. Today I've got not just one but two MSI boards on the bench. First one is MSI MAG B550 Tomahawk, model 7C91 version 2.1. And the second board I have is an MSI B550A Pro, model 7C56 version 2.1 as well. So let's start with the Tomahawk, go through its issues step by step, and afterwards we'll check out the Pro. Interestingly, it has a very similar issue to what I've shown before. The board powers up fine without CPU, but once you install a processor in the socket, it refuses to turn on. It's quite feature-wise, it's quite a capable mid-range board. It comes with dual Ethernet ports, one 2.5 gigabits and 1 gigabit, USB-C port. It has also PS2 and flash bias button. Let's measure resistances on main power rail before powering this board on. Volts, kilo ohms, 5 volts, ohms, 12 volts, kilo ohms as well, minus 12 volts, mega ohms, CPU 12 volts, kilo ohms, and CPU to V core, mega ohms, and the V core, that's kilo ohms as well. We have no shorts, and I guess we can try power on to check if we have a power button reaction. Okay, let's power on. We have 84 milliamps, and let's put the button. Pressing and no reaction. Well, this tells us the board is stuck right at the beginning of the power on sequence. Those who haven't seen my previous video where I explained the aim4 power on sequence step by step, I leave a link for you to check out. So let's check if we have standby voltages such as 5V dual and 3 VSB. But before we check, we should probably disassemble it a little bit and to remove the heatsinks for the M2s. And we have to remove the heatsink for the PCH. So we have 5V dual on this chip right here. The voltage mode, and I guess we can find a nice ground here. Let's see if we have 5V dual. And we do, we have it. Here we have a 3 volts, 3 VSB. Okay, let's check if we have an inactive resume reset signal. The signal is named RSMRST and it is active low, which means it is asserted by pulling it low. The same as power button signal. So we can find this signal on the FAT over here. I will switch to the microscope.
I also found a small area of damage near the mounting hole. However, no traces were broken, so this damage cannot affect the motherboard startup sequence. In the video you can see two MOSFETs, the larger 3-pin chips. The RSMRST signal should be present at the drain of the left MOSFET. Its source is tied to ground. The gate is controlled by a combined signal derived from two power good lines, VDDP and CPU 1.8 volts. Under normal conditions, the gate should remain low. If the gate goes high, the MOSFET will conduct, pulling the drain and therefore RSMRST down to ground, something that should not occur during normal operations.
So, for us it means the RSMRST is pulled low, either by the SIO or the processor for some reason. I guess we have to make a visual inspection of the motherboard before diving deeper into a motherboard power on logic. Let's throw it under the microscope and check it out.
As you can see, there are a couple of knocked-off components right next to the SIO. Now, according to the board view, this tiny resistor is actually responsible for sending the 5VSB DET signal over the SIO. And that signal is basically the SIO's way of checking, hey, do we have standby power or not?
So, if that resistor is missing, the SIO never sees the 5VSB rail, and without it the board just refuses to wake up. Instead, the SIO halts everything and pulls RSMRST low. So yeah, this tiny little part could be the whole reason why the motherboard doesn't even try to power on. Alright, let's solder those knocked off components back in place and see if that's all it takes to bring this board back to life. If it works, this could turn out to be an easy peasy repair. Okay, so I've soldered two components. It's resistor, 2.4 kilo ohms and 2.2 nanofarads capacitor. So now let's probe for RSMRST signal, which should be high. Okay, turning on, I have, wow, way more, 258 milliamps. So our RSMRST.
The RSMRST signal later went high, which confirms that we are on the right path in the startup sequence.
I will connect my button. Okay, so pressing. Okay, we have a reaction. need a heatsink for my CPU. And do we have any other LEDs light up here? Okay, let me connect the HDMI. Maybe we will have a pause screen. Okay, I connected HDMI. I'm gonna install the heatsink here. I'm gonna show you the pause screen output here. It's gonna happen. Turning it on so you can see the current consumption over here is 58. Pressing the power button. We have LED CPU. Next should be DRAM. Okay, VGA. And boot. Do we have a pause screen over here? And we do. Okay, we've got a pause screen. That means the board is most likely fixed. From here is just need to go through final diagnostics and some stress testing before we can officially mark it as fixed and working. Meanwhile, let's switch over to our second motherboard, the MSI B550A Pro. The MSI B550A Pro. This board is a bit simpler, but it still comes packed with plenty of useful feature. I'd say the main downside of both these boards is that neither comes with a built-in Wi-Fi module. Alright, let's jump into the diagnostics. We'll start by measuring the resistances on the main rails and then see if this board powers on. Let's power on. All resistances are normal. Okay, power on. It's 59 milliamps. And pressing the power button, and no reaction. Almost the same story. Let's check with 5-volt dual and 3 VSB. Remove the PCH heatsink and see we have a RSMRST. So let's see if we have 5 volts. We can measure it over here. Let's do it under the microscope.
During the measurements, I was able to confirm the presence of 5-volt dual, but 3 VSB was missing.
Okay, unfortunately we have no reaction to the power button, and it seems like we don't have a 3 volt standby power. So I would follow to a visual inspection. Okay, I see the flash, the bias chip is resoldered.
During my inspection of the back of the motherboard, I discovered many missing components. They don't appear to have been accidentally knocked off. Rather, it looks like this board was used as a donor. That's a bad sign, and my chances of repairing it drop significantly after seeing this. Who knows what components were originally removed or swept here. However, I'll still attempt to restore the missing components. Most of them are just resistors and capacitors, along with a single inductor in a logic MOSFET, all of which I already have in stock. Since the BIOS chip showed clear signs of previous soldering, I decided to reflash the correct BIOS, just in case. It would be very disappointing to spend so much time on this board, only to later discover that the issue was a corrupted BIOS.
So after restoring all the missing components, replacing what was gone, and even refreshing a fresh BIOS with the programmer, unfortunately this board still refused to power on. I traced the power segment as far as I could, but I got stuck at the slip S3 signal. Never goes high, and since that signal depends on the CPU driving some internal logic, without a schematic for this exact revision or the official power segment for this board, it's nearly impossible to pinpoint the exact culprit. Sometimes repair reaches this point, all the obvious issues are fixed, but the underlying fault is buried too deep in the chipset or CPU domain to confirm without documentation. It's a reminder that not every board can be saved, even with all the tools and effort put in. That said, this process still has value. We learn a lot, going through the diagnostics, checking the rails, spotting missing passives, and piecing the board back together. And even if the end result isn't a working system, it shows the reality of board repair. It's not always a win, but every attempt builds more experience. If you enjoyed following along, don't forget to like the video, subscribe for more board level repairs, and drop a comment if you are running into similar dead-end situations with your own projects. Thanks for watching. See ya!